17E is called anti-differentiation, or known as indefinite integrals. I'll explain why it's called indefinite soon. There's a reason why it's called indefinite. Now, let's read some notations. This here means delta, so the change in. Now, usually we say change in y over change in x, right? Well, this is your y. That is your y. So it's just saying delta y, delta x. That's what this means. It's just that sometimes they don't use the notation y, so they use f of x. So in other words, this means the derivative. But we also know to write another way of writing the derivative is f dash of x. Means the same thing, right? Well, here's the logic then. If I gave you f of x is equal to x squared, let's see if you know your power rule. What is the derivative of x squared? Can I please have Milena? Derivative of x squared is 2x. Very good. So this is called deriving. So derivative goes forward. But if you want to go backwards, that's what we're doing today. 17E is called antidiff. And the rule is exactly the backwards of what you did for power rule. So let's think about what you did for the power rule. Power rule was you drop the 2 to the front, and it was times. That's a key thing. I'm going to write here times. Then what else did you do? How did you go from power of 2 to a power of 1? What did you do? How to go from a power of 2 when you're deriving to a power of 1? What did you do? 2 to 1. Minus 1. So antidiff is the opposite of that. Instead of timesing the 2, we're going to divide. And instead of minusing by 1, we're going to add 1. Literally. So I'm going to show you the formula, and then you're going to practice doing some antidiffs on some problems here. Okay, so this was minus 1 to get there, right? So 2 minus 1. Then the antidiff is everything opposite. So you are going to divide by the number, which is 2, and then you're going to add the power by 1. Okay, so let's have a look at the rule. See this rule here? This is the only 2 you should learn. 2a, I'm going to box it. Looks scary, but it isn't. This symbol here means, whoops, antidiff. Technically it's integration, but I'll talk about that later on. That means antidiff. This is a power rule. That's a power function. So x to the power of n, and a is the number in front of x. So what's the rule? So you still have the a, but notice the bottom, you're dividing by n plus 1. Why are you dividing by n plus 1? Well, let's think about that scenario again. You told me derivative was 2x. But where did this 2 come from? That 2 came from the power. So if the current power is 1, well, how do I get to 2? You have to add 1 to it. That's why you then bring it up to 2. So that's why it's n plus 1. The n plus 1 is literally just bringing this one. 1 plus 1 is 2. So the power is 2. And to get rid of that 2, because that's times, you have to divide. It's the opposite of each other. I know when you're looking at the formula, it looks totally confusing, so we're going to do a practice, okay? So here we go. Let's do a practice. So first one, this is the only rule you need. This is a nice to know. Okay, this is a nice to know. So number 1 and number 2a. You technically don't need to know 2b. I wrote it in case you guys want to look at some year 12 questions. Then 2b is useful. But otherwise, all you need is 1 and 2a. All right, here we go. Let's do a practice. Let's look at this one. 3x squared. Let's antiderive each one. So I've got 3x squared, 4x cubed, and 3. Let's do them individually so you get used to it, okay? So antideriving, this is the symbol. Looks like a slight S. When you antiderive, you must have dx. Write that as a note. Must have. If you don't have it, you lose marks because it doesn't make sense for antidiffs. Let's do the rule now. See, the rule was ax to the power of n dx should equal to n plus 1. So a times n plus 1 divided by n plus 1. Okay, that was the rule. Let's try it. What's my n? According to this rule, what's my n in this case? What's the n for this problem? What's my n? N's the power 2. Okay, n is 2. So here's my n. N equals 2. A is 3. Okay? Now, according to the rule, A still is the same. I know the formula was up here. Whether it's up here or whether you write it out here means the same thing. Yeah, I'm just separating it so you can see. So A is still there. So it's still 3 times, and all you had to do was add the power by 1 because power rule means subtracted. So in this case, we add the power by 1, so 2 plus 1 over 2 plus 1. That should give you now 3x cubed over 3. Which is convenient. The 3's have to cancel out for you to get x cubed. Now, if you wanted to test this, does it not make sense if I asked you, what's the derivative of x cubed? So you would have said, bring the 3 down minus the power by 1. That's how you would have got 3x squared. See? X cubed, power rule would have gave you 3x squared. So bring down the 3 minus the power by 1. That's how you got 3x squared. But why was there that division? It's because you're going to times by 3. So you have to do the reverse. That's why we divided by 3. That's why it cancels out. Okay? Let's practice again. We're going to do the next one. Copy it down. We're going to move this across. All right, let's do the next one. Next one was plus antidiff of 4x cubed dx. Let's follow the rule. A is 4. N is 3. According to the rule, A stays the same because it's a constant. It's a dilation factor, so we keep the 4. Times, now the power is 3. So if you want to go back to what it was before you derived it, it should be x to the power 3 plus 1. But in the power rule, we times whatever that number was. So if you're going to times it, you have to divide it. 3 plus 1. So divide by 3 plus 1. Check what happens here. The 4 should cancel out because you end up with 4x to the power of 4 over 4. Cancels out to give you x to the power of 4, which makes a lot of sense. Because again, if I asked you to derive x to the power of 4, you would have said, bring the 4 down, minus the 4 by 1, and that's how you would have got 4x cubed. So we're just going backwards. It's that fraction bit that a lot of students get confused. Because they're used to timesing and subtracting, they're not used to dividing and adding. It's the same thing. Yeah, so you're just adding the power by 1 to get back, and that gives you this. Once you kind of do a couple, you start to get the idea to do the first 2. The one that students tend to forget is the last one. It's kind of like derivatives. Plus 3. So how do you do it when it's plus 3? Anti-derive 3 delta x. Here's my tip. If you wanted to do the last one, anti-derive 3, well, right now there's no x's, right? Put in an x for yourself to make it easy. Because x to the power of 0 is just 1. And 3 times 1 is still 3. So why not just put the x in so that you can still use the formula? Here we go. A is still 3. Power is 0 plus 1 divided by 0 plus 1. See, by just putting in that x to the power 0, it makes it all similar again. And that gives you 3x x to the power of 1 over 1, which is really the same thing as saying 3x. So when I ask you, what is the antiderivative of 3x squared plus 4x cubed plus 3? What I want to see, next time, don't break it up into 3 pieces like the way I did. Just a lot of work there. You're meant to write it all in one go. So 3x squared plus 4x cubed plus 3 delta x should equal 2. And then you're meant to write your answer as x cubed plus x4 plus 3x. Okay, and if you want to see if you've done it right, just derive them. Derive x cubed, do you get 3x squared? Derive x to the power 4, do you get 4x cubed? And if you derive 3x, do you get 3? That's a hint that it is correct. Now, there were 2 parts I said that you will lose marks if you don't write it in. Mark number 1, if you don't have dx in your integration, you lose a mark. Your next one, if it's an indefinite integral, which this whole exercise is, if you don't write this in, you will also lose a mark. You must write plus c. And I'll explain what that is, and that will conclude our lesson for today. Okay? The reason why this is called indefinite integral is because we don't know what that last number could be. It's a plus c, meaning plus a constant number. Why do we have a plus c? Well, here's a couple of logical reasonings. You see, if I asked you this, y1 is equal to x squared, let's test it. Numafi, what's the derivative of x squared? 2x. If I gave you a second one now, what is the derivative of x squared plus 3? Can I please have Mete? 2x as well again. If I gave you now a third one, x squared minus 5. What is the derivative here? Let's go with Christina. This one. 2x. Can you see all 3 of them are different? You see that? So I want you to pay attention to this bit, why you need the plus c and why it's called indefinite. This is x squared, you told me derivative is 2x. This is x squared plus 3, you told me derivative is still 2x. This is x squared minus 5, you still told me the derivative is 2x. So if this is the derivative, and I ask you to go backwards now, if you were to antiderive each one, which one is it? You see, if you antiderive 2x, you could get x squared plus 3. If you antiderive 2x, you could get x squared. But then if you antiderive 2x, you could also get x squared minus 5, but it could have been any number. And because of that, that's why we call it indefinite, because it's not definite what the answer can be. That's why you have to put a plus c. Because it doesn't have to be a number. It could have been minus 5.1. It could have been minus 5.01. And the derivative still is 2x. That's why when you find the antiderivative, there is this whole possibility of constants that we don't know. That's why you have to have a plus c. So 2 marks. If you did not put a plus c, you lose a mark for the answer mark. If you didn't do delta x, you lose a mark for the method mark. This is a method. This is an answer mark. Okay, so both is important all the way up to year 12. Cool? That's it for today's lesson. Next lesson, we'll just practice this again. And then you have some time to work on chapter 18 applications with your CAS. And then I'll show you how to use your CAS as well. Shortcuts for derivatives. Shift plus gives you antidiff. So if you press the shift button and you press plus, that's minus, that's derivative. If you did shift plus, that's antidiff. Okay, think of minus as minusing the power. That's why it's derivative. And antidiff is adding the power. That's why you do shift plus, get the antidiff. Okay? But I'll talk more about that next lesson. At the moment, it's 10:06, and we did 2 very express sessions. Because remember, next week, I will not see you until the SAC, which is Friday. Okay, SAC is on Friday next week.